Now let's see F distribution in practice. So F distribution is a continuous probability distribution that arises in statistics and is used in hypothesis testing. Analysis of variance is nothing but ANOVA and regression analysis. The F distribution has two parameters. One is the degree of the freedom of the numerator and the denominator denoted by df1 and df2 respectively. The F distribution is the ratio of two chi-square distributions, specifically if x chi-square df1, that's a degree of freedom 1, and if you have another variable or another sample or another population, that's y, and chi-square of degree of freedom 2. Total you will have a 2 chi-square values. Then the ratio of chi-square with degree of freedom 1 and the chi-square of degree of freedom 2 follows an F distribution with parameters of df1 and df2 that we have done in our previous video. So there we have explained how to build F distribution itself. Then the F distribution is important in hypothesis testing, where it is used to compare the variance of two samples. It is also used in ANOVA, which is a statistical method used to compare means of two or more groups to determine if there is a significant difference between them. The F distribution, so then in regression analysis, very important. In regression analysis, F distribution is used to test the overall significance of a regression model itself. So which involves determining if the regression model is statistically significant or not. Like other probability distributions, the F distribution can be plotted using a probability density function, PDF. We call it as a PDF, and a cumulative density distribution function. We call it as a CDF. So the shape of the F distribution depends on the values of df1 degrees of freedom 1 and df2 degrees of freedom 2. So the PDF probability density function is typically skewed to the right and has a long tail towards a positive side, whereas the CDF, that's continuous, that's a cumulative distribution function, is a continuous function that starts at 0 and approaches 1 as x increases. So in summary, the F distribution is a key probability distribution used in statistical analysis and is used in hypothesis testing. So ANOVA and regression analysis, its shapes depends on the values of the degrees of freedom, and it can be plotted using either PDF, that's a probability density function, or cumulative density function. So these are the two formulas widely used to calculate the F statistic. One is F distribution is the ratio of two variance estimates. Either you can go with the variance estimates, or second one is the widely used one is the ratio of two chi-squares, each divided by its degrees of freedom. You see that? This is what we have used to build a F distribution from the scratch. So now let's look into the one or two examples to understand how this F distribution makes our lives easy as a data scientist. So let's take an example. So this one is, let me put it as F distribution here. Of course, we used as an example. So suppose we will take a field of finance. Example is from the field of finance. Suppose we want to determine field of finance, and we want to determine whether there is a significant, the word significant is very important, significant relationship between a company's financial performance and its stock. Let's see, and its stock price. Okay, so this what is our problem statement. To test this condition, we can perform a linear regression. So first thing we have to do is step 1, we have to perform a linear regression analysis where EPS is the earnings per share, is the independent variable, and stock price is the dependent variable. Okay, so this is what so our dependent variable is stock price and the independent variable is EPS. So you can show it like this. So stock price is equal to M times EPS plus some constant. So this one will be our equation. So now after running the regression analysis, we obtain a regression equation and it calculates an F statistic also. So step 2 is to run a regression analysis. So after running a regression analysis, we obtain a regression equation. So we'll obtain a regression equation and then we'll calculate F statistics. Very important, F statistic. So now once you have your F statistic with you, the F statistic measures the ratio of the variability in the dependent variable explained by the independent variable to the unexplained variability. So if the F statistic is sufficiently large, so if F statistic is sufficiently large, we can conclude that the regression analysis or regression model is statistically significant and that there is a significant relationship between EPS and the stock price. There ends the matter. See that? Got it now? How the F statistic is useful? Why I am screaming about F statistic and understanding the fundamentals of the F statistic. That is the reason. Many of the data scientists I observed, they know how to interpret the F statistic, but they don't know what is F statistic. Kamal ka baat hai yaar. Okay, so after running, so once this is done, so that's it, almost you're done. So like so we can conclude that so we cannot conclude that the model is significant and that there is a significant relationship between the two variables if the F statistic is small. So here we got the large F statistic, so that's why we are saying there is a significant relationship between them. But if F statistic is small, then what you will do? If F statistic is small, so we cannot conclude that the model is significant significant, and there is a significant relationship between the two variables. So therefore the F distribution is used to test the overall significance of the regression model. Very important. So the F statistic or distribution is used to test the overall significance of the regression model in whatever the variables may be. Let's put it in this way. Okay, so now what we will do is we will take a data set and we will do some analysis, and let's see how it works. Okay, let's take first step one is let's create an this is another example. This is not the same example, but this time I want to use a data set and then do some analysis so that I can prove it. So step one, so let's create an hypothetical data set to demonstrate the use of the F distribution on the regression analysis in the context of finance. That's what I want to say. Okay, so for me, let me take a data set. Yeah, it's supposed to be here somewhere. Yeah, so this is my, yeah, so let's create a hypothetical data set, and this is our data set. Data is this. Yep, you can see that earnings, dividend payouts, market volatility, interest rates, and stock price. Okay, this is what is our data set. Now you got your data. Suppose we are interested, so problem statement, so we are interested in predicting the stock prices of a particular company based on various factors such as its, I'm putting the respective variable names. So our stock price is our dependent variable, and then rest all are independent variables. So based on its earnings, that is the first one. Then dividend payouts, then market volatility, and interest rates. So here you got your dependent variable, and then 4 independent variable. Okay, so now let's collect data on, so these so we have collected, this is the data set we have here. So this data set consists of consecutive 20 quarters, and what we can do is we can perform a multiple linear regression analysis to predict the stock price. So what we can do here is perform a multiple linear regression analysis to predict the stock prices. Okay, let's do that. So now let's begin doing the analysis. So as you all know that the minimum requirements to train model and test model, let's do that. But before that, let's import the required libraries, and also import numpy as np. Then the most important one, import stats model. stats model dot API as SM. So all the imports are done. So now the most important one is to train our data. Okay, let's split the data set into predictor and response variable. These are the names we give it in data science. Predictor and response variable. So x is our capital X is our independent variable, which is the one which predicts the target variable. So let me check. So data of what all variables are there? Earnings, then dividend payout. Sorry. Okay. What's the issue here? Let me directly copy from there what we can do. Yeah, it's capital D. Dividend payouts. Then yeah. So once dividend payouts is done, then market volatility. Okay. Market volatility. Let me copy it from here itself. Once market volatility is done, the final one is interest rates, nothing else. Now is interest rates. Let me cross check. Yes, you got the 4 data frame with the independent variables. Okay, so now it's time for dependent variable or response. So data of stock price. If you want to cross check, let me do that. So and here it is. Got it? Stock price. Done. So the data has been split into predictor. The first one is predictor, X is predictor, and response variable is Y. That's it. Now it's time to fit into. So now let's add a constant term to predictor variables. So let's add a constant term to predictor variables. So capital X is equals to sm dot add constant of x, and let's check x, and here is your constant term. All are ones. That's okay, it doesn't matter. We have added the constant column also. Now it's time to fit into the model. So fit OLS model. So model is equal to sm dot OLS of y, that's our response variable, and x is our predictor variable. Then fit it. The model has been fitted. So now all done. Now it's time to calculate the F statistic. Calculate the F statistic and p-value for overall significance of model. So F underscore statistic is equal to model dot F value. Yeah, sorry, F. Okay, just F value, not F p value. Okay, done, because this is an attribute. Then now I'll get the p value. P value is equal to again model dot F underscore p value. This is what I'm telling. That's it. Now let's execute, and so let's print the respective values. Let's print F statistic and p-value. So print F statistic is F statistic, and similarly print p-value, sorry, p underscore p-value is p underscore value. Okay, model dot, there is an issue. Or OLS results object has no attribute F value. Let me cross check this. Oh, got it. This is F value. And here is your F statistic and Y statistic. So these are the only two things we got. So in addition to that, I want more information from the model. So what I'm going to do is I'm going to call upon the model. So I'm going to ask the model to give the summary of uh, multiple linear regression model. So print model summary. So print model dot summary, and here is your complete model summary. This is your F statistic 124. It's very strong. Then you got the p value 2.51 and the probability, respective probability value for the PF statistic. And this is completely regression, multiple linear regression results. This is the dependent variable or stock price, and then R squared is 0.971. Fantastic. And adjusted R square 0.963. That's okay. Then method least squares. Here is the F statistic 125. It's no, rounded up. Then F statistic probability 2.51 that you can see here. And then log likelihood is this. AIC, BIC also given. So number of observations and DF residuals and DF model. And if you come down here, you can see the remaining data. So how they're dependent and the probability. This is using T distribution. This is using T distribution, probability of T distribution, respective values. Okay. And this here you can see the skewness and the kurtosis also. Okay. So that's what, this is what I want to show you how we will use it and what it says finally, what you take out from this. So if you look into this data, the market volatility, if you look into this one, the whole response, the model summary. In this data set, we have our predictive variables, earnings, dividend payouts, and market volatility and interest rates. And one response variable, that is stock price. So we perform a multiple linear regression analysis using these variables and obtain these results. So R squared is equals to 0.971 and F statistic is equals to 125 and P value is equals to 2.51. So based on the R squared value, we can say that the model explains 97% of the variability in the stock price. Fantastic. The F statistic tests whether the overall regression model is statistically significant or not. In this case, F statistic is 125. Okay, it's 124.999. So with a p-value of 2.51, indicating that the regression model is statistically significant at a significance level of 0.05. So therefore, we can conclude that the multiple linear regression model using this predictor variables in earnings, dividend payouts, market volatility, and interest rates is statistically significant predictor of the stock prices. This is where you use your F distribution.